With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, let's start the question. So we have been given a chlorobenzene derivative over here. On the arrow mark, we can see that the first reagent is alcoholic KOH, whereas the second step of the reaction is polymerization in a free radical mechanism mode. So let us do it, yeah? So basically, let us first of all be clear with this concept that alcoholic KOH is the dehydrohalogenation causing reagent. Okay, what is it? Dehydrohalogenation, which means it would be removing a hydrogen and a halogen. Yes, so the location from where the halogen would be removed, the carbon adjacent to it containing a hydrogen over it, yes, would be removed equally. Now at that point, the formation of an alkene takes place. Yes, this results in the formation of an alkene, and that alkene is the major one which is going to be most substituted. Yes, so supposedly, as in this case, we can see we are having two carbons which are bearing hydrogens just adjacent to the carbon bearing chloro group. So in this case, both of the carbons are totally different, yeah, but then the dehydrohalogenation would be caused for the carbon which is left to the chloro bearing carbon. Yes, in fact, if at all I was labeling this as 1 and 2, then C1 would be losing the hydrogen and forming the alkene, which would be major in that case. Yes, and what about polymerization? So polymerization is obviously going to be the breaking of the same double bond, breaking of the double bond into free radical fragments, yes, into free radicals, and giving us a polymerization reaction. In fact, the units will combine together to give me a long chain of the said polymer. Yes, so first of all, let us perform this reaction. Yes, so I hope everyone is ready. So here we go. So we are having our chlorobenzene. Please take care that we are placing the locations properly. Here I'm purposely going to pluck out a hydrogen. Yes, then there's a chloro group, and then there is a CH3. So these are the bond details of the said molecule. And as suggested, we are having alcoholic KOH in the very first step. So that will enable the removal of halogen, yes, and hydrogen. Okay, and that would result in the formation of the double bond. So here we go. Now in this case, if at all there's a question in your mind that why didn't the chloro group on the benzene ring get substituted by the OH? Yes, so definitely the reaction which you are talking about, if this thought is lingering in your mind, then the reaction which you are talking about would be an SN2 type, and that is not possible with an aromatic ring. Yes, it's quite difficult. So we cannot have the substitution of this chloro group at all. It would remain intact. Other than that, what we get is the formation of an alkane over here. Yes, so in this case, the OH over here is a base. Okay, it would be acting as a base and not as a nucleophile. Okay, fine. Now, what next? The next thing is the polymerization. And polymerization would be done through the free radical mechanism mode. So in this case, N units of this alkene would be undergoing homolytic fission. Yes. So let me write this molecule or this free radical fragment . This free radical fragment in this manner. So look at this after homolytic fission, how would it look like? So here I'm having CH dot, yes, and here it's going to be ch dot once again. Let me keep this ch3 in the downward mode, and n number of these free radical fragments would be combining with each other, yes, and hence giving me a chain-like structure. Yeah. So basically what is going to happen, these are going to be the points of free attachments, okay, as has been denoted by a dark spot over there, yes, and hence the polymerization gives me the formation of the chain structure, that's a polymer, wherein the chloro group is present on the para position, yes. Let me extend out this free attachment over here, and let me make a bracket to indicate that yes, these would be the points of attachment with such units on either sides. Yeah. So CH3, and either ways I put it here or on this side, it's one and the same thing. So I'm just putting it on this side so that it can be indicated well. And in the subscript, I'm writing N, which indicates that N number of such units are going to hold hands together. Yeah. So this is what is your product after polymerization. And it matches with the option number A. Yes, or option number 1, as it can be said. Okay. So we mark option number, oh, I'm sorry. That was by mistake. Yeah. So we mark option number 1 as the product or as the answer to our question. I hope you understood the explanation. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.